SubstraTEE is a framework for Parity Substrate, allowing to call a custom state transition function inside a trusted execution environment, namely an Intel SGX enclave, thereby providing confidentiality and integrity. The enclaves operate on an encrypted state which can be read and written only by a set of provisioned and remote-attested enclaves. What substraTEE aims to enable: confidential decentralized state transition functions, private transactions, private smart contracts, off-chain confidential personal data records, decentralized identity with selective disclosure, subscription-based content delivery networks, scalability by providing a second layer to substrate-based blockchains, off-chain smart contracts, payment hubs, trusted chain bridges, trusted oracles. Rust SGX SDK helps developers write Intel SGX applications in Rust programming language. Good news! Our paper building and maintaining a third-party library supply chain for productive and secure SGX enclave development has been accepted by X20C at Track. See you guys in Seoul. We open source GBDTRS, a lightweight, amazingly fast, memory-safe, and trustworthy gradient boosting decision tree implementation, and the paper has been accepted by ESAN 19. It is optimized for SGX. To achieve better security, we recommend developers to apply non-bypassable security paradigm to the system design and implementation. To help understand this project and know how to use it, we are writing some wiki articles. Please send me an email if you'd like to see other topics. We'll add it as soon as possible. Trusted execution. We have become accustomed to the fact that we have to trust our IT administrators. While these administrators used to be in-house employees at our companies, today we often work on rented cloud platforms. These administrators can read and modify all the data processed on any machine they manage. Unfortunately, this ability extends not only to known administrators we trust but also to hackers who can obtain administrator privileges. No company, no matter how qualified, is immune to such attacks. Enter Tees. You may envision a T as a coprocessor that manages its own cryptographic keys and only executes programs whose hash, or fingerprint, corresponds to the original code. The manufacturer of the processor guarantees, by the design of their hardware, that nobody has access to the internal keys of the T or can read its memory. Moreover, the manufacturer can authenticate each T and provide remote attestation to a user to confirm that her untampered program is actually running on a genuine T, even if the machine is physically located in an off-site data center. T's promise, in short, integrity and confidentiality of computation. You should be aware, however, of possible security threats. Assuming we trust T manufacturers' integrity and design competence, T's allow us to execute any state update without sharing our data with the blockchain validator or other users. Private token transfers, private smart contracts, and private state channels thus become possible and relatively cheap. SubstraTEE leverages the confidentiality guarantees of TEEs, namely Intel SGX. Whatever is computed inside substraTEE worker enclaves can't be observed by the network, nor by the operator of the worker service, nor by the root user, nor a cloud provider admin. What substraTEE can't provide is network layer privacy. That's what Tor and NIM are for. SubstraTEE with direct invocation is a second-layer technology. It allows to do state transitions without the individual transactions hitting the blockchain. More transactions per second, because no global consensus must be reached on individual transactions. Less latency because there is no need to wait for block inclusion. Disk usage and load balancing can be scaled horizontally. SubstraTEE also features sharding. Chain interoperability is considered one of the more pressing challenges for blockchain technology. With substraTEE, we've built a tool that is well suited to solve trusted chain bridges, because the integrity of code execution is guaranteed by a T. See our proposal for Polkith Bridge.